All right, and I don't know, maybe the mistake is on the colors, maybe it's a detail I'm missing, maybe the way the numbers are drawn. So think about it, and later we get back to this bell work. Okay, what is the mistake? I'm still not sure. Good morning, John Lee. Well, let me talk about something really important. And again, maybe this is going to be the last proper meeting, and maybe we will not have the chance to talk again like this next week. But I would like to talk about the PERT exam. It is scheduled for next week. Seniors have to take the PERT exam on May 18, so you have to get back to school on Tuesday from before 7:30. Arrive here before 7:30, and you also will have makeup days, but try to come on 18, because we have to close your grades as soon as possible. The 21st is going to be too late. There are makeups on the 19th and 21st, but I think the 19th, 20th, 21st, but then 21st is going to be too late. Try to be here on the 18th, or the worst case scenario on the 19th. 9th, 10th and 11th graders, you will have the PERT exam on 19, 20 and 21 from 7:30 to 9:30. Okay? If your score is 97 or more on your last PERT exam, you don't need to take this again. You don't need to come back next week. But if your score is 96 or less and you are senior, right, you have to come back, take the exam, or this might affect your grade. This is not a requirement for graduation, but if you don't take the exam, you're going to use your previous grade, your previous exam. And if the grade is too low, or even if you didn't take the exam at all, this will affect a little bit your grade. If you have an A, it can go down to a B. So that's the only bad thing that can happen. But I think it's a very good opportunity to take this, to improve your grade, and also to have a placement grade for college. Just a minute, let me take. Not sure about your grade, check on Focus. Or if you're not, if you cannot find or Focus, send me an email. I send the grade. I send you a reply with your grade on the last PERT exam. Okay, so if you're not sure if you have 97 or more, and for grades 9, 10, and 11, you must have a score of 414 or more to work to not need to come here for the next week exam. Okay, if you have 113 or less, you need to come here for to take the exam. The grades 9, 11, 10, and 11. Any questions? Any questions about the PERT? And don't be too stressed about this PERT exam. It's a good chance that the school is giving to you to improve your grade on a placement exam. That's good for college application. So don't need to be stressed, and take this chance. Do your best. And it's going to be good for you, and also in the future, if you're not, even if you're not applying now, but if you decide in the future to apply for college, it's going to be good to have this placement exam grade. All right, moving on. Any questions? No questions? Let's move on to the review of finding a sum from sigma notation. That's what we have seen yesterday. We used this new symbol to find a sum from sigma notation. And sigma is this Greek letter that is used to represent the sum of the terms of a sequence. And I want you to remember, this is the main thing I want you to remember from yesterday's lesson. What means this sigma, this Greek letter? When you find this out, when you see a question like that, you're gonna remember, oh, this is sum. You have to add the terms of a sequence. And it's defined by the terms from n equals 1 to n equals 4. And the formula is after the sigma. And in this case, in this example, the formula is n cubed. Right? So n cubed is our formula. And yesterday we solved this. So since we need to add the terms from n equals 1 to n equals 4, we plug in n equals 1 and onto the equation, n cubed, 1 cubed, plus n equals 2, 2 cubed, plus n equals 3, 3 cubed, and n equals 4, 4 cubed. The sequence is 1, 8, 27, 64, right? So we add these 4 terms together and we find the answer to this example. What will be the answer for this example? What is the number, the solution? Send me a message and tell me, help me. This is going to be the last time I will ask for help. All right, thank you, Amber. Thank you, Ricardo. Maybe 100? Maybe 100? Thank you, Genesis. Nice. Good. Let me take notes. Thank you. And add some grade, add some points. Some participation points. Thank you, Roberto. So let me add some participation points to Roberto as well. All right. I think I will. Let's check because I'm confident you got it right. So we need to add 1 plus 8, 9, plus 27, 36, plus 64 equals 100. Yes, 100 is the right answer. 100 is the right answer. Great. And you can see we are adding all the terms. Not all the terms, but all the terms from n equals 1 to n equals 4, as defined here on the sigma notation. Great, excellent. Remember about the sigma notation that represents the sum of several terms as defined. Now let's move on to the last topic of chapter 10. We are talking about sequences, and we will learn how to identify 2 special cases of sequences. One situation, one case is the arithmetic sequence. How do we identify an arithmetic sequence? And the definition, it's here. Arithmetic sequence is when the difference between consecutive terms is a constant. To explain it in simpler way, look at the example. Look at this, really big. We have 4, 7, 10, 13, and 16. Every step you need to add what? 4 and 7, 4 plus 3, 7. We add 3, 7 plus 3, 10, 10 plus 3, 13, and 13 plus 3, 16, right? So every step, every next term, we add a number. We're gonna add 3. If we add a number to find the next term, or if we subtract a number to find the next term, this is a arithmetic sequence. Okay? Very simply saying, this is the definition. If you add a number or subtract a number to find the next term, this is classified as an arithmetic sequence. Now, another situation, another case. This is one case, arithmetic sequence, another case. Geometric sequence. A geometric sequence is a sequence in which each term after the first term is a constant multiple of the preceding term. Now, instead of adding or subtracting, let's check this sequence, this example. See what we're going to do. We have this example. To find the next term, if we add, it's not going to work. We'll work on the first one, but it's not going to work on the next or the next. So we're not supposed to add. Now we will multiply. So 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. When you multiply by a number or divide by a number to find the next term, you have a geometric sequence. Right? So simple. Let's maybe you can work on a few examples to visualize, to illustrate. We have these 2 special cases, and you are able to identify. Look at those examples. Just a little bit less. Look at those examples we have, and the first one. Let me write bigger. 0, 5, 10, 15, 20, and on and on and on, like this. We can find the next term of the sequence by adding 5, right, to the previous term. So add 5, add 5, add 5, and you can find the next one, also adding 5. That means this is geometric or arithmetic. If you're adding a term, if you're adding a number to the term, this is arithmetic sequence. Okay? Next example. Now we have, it's kind of, it looks like the previous one on the first terms. Then we have 20, 40, and on and on and on. If we try to add 5, it's going to work just for the first term. 5 plus 5, 10. But if you try for the second term, it's not going to work, right? It's not 20. So no, don't add 5. Don't add 5. It doesn't work. On this case, we have to multiply. Multiply by 2, we have 10. Multiply by 2, you have 20. Multiply again by 2, you have 40. Keep multiplying by 2 to find the next terms. And this, if you multiply or divide, you have a geometric sequence. So this is geometric sequence. Okay? And the last sequence is just an example of a sequence that you cannot find if it's geometric, if you cannot see if it's arithmetic. Let's try. 28, 32. If you add 5, it's going to work for the first term, but it's not going to work for the other terms. So don't add 5. It's not arithmetic. It's not arithmetic, right? Now try to multiply by 2. Multiply by 2, and it doesn't work either. That means it's not arithmetic, it's not geometric. You can say it's a random, maybe a random, but we cannot classify in one way arithmetic or other way geometric. Maybe it's a random sequence. On the quiz, we will only have arithmetic and geometric sequences, so you find out the rule and classify if it's arithmetic, geometric, and we don't have any examples of random sequence on the quiz. Okay, only arithmetic and geometric. Questions? Do you have questions? Any questions? And the answer to the bell word, the mistake is on the word sequence. It's not sequence. The right word is sequence. And again, sorry, it's just a silly math puzzle. It's not a math puzzle. It's actually a silly puzzle, a silly riddle. And you can write, the mistake is sequence. The right word is sequence. Now let's move on and work on our quiz. Write the nth term of the arithmetic geometric sequence. If not possible, write x. All the questions will be possible. All the questions, the answers will be arithmetic or geometric sequence. We don't have any random sequence, okay? So, and you have to answer two things for each item. For example, item A, we have the sequence 7, 12, 17, 22, 27. We can identify that adding 5 on each step, on each term, we find the next term, right? By adding 5. So the next term of this sequence is 27 plus 5, 32, is the right answer. It's one of the questions. And the other question is this sequence arithmetic, geometric, or random? If we are adding a number to the term to find the next one, is an arithmetic sequence. Okay, arithmetic sequence. Now I'll give you 1 minute, and after that we can work on more questions, even other questions. If you let me show the letter L. It's also kind of look like the letter J. We have 1, 4 over 3, 5 over 3, 2, 7 over 3, 8 over 3. Those integers we can represent as a fraction as well, just to have all the sequence as fractions. Look, 1 we can write as 3 over 3, right? And 4 we can, and 2 we can represent as 6 over 3, right? And now we can make sense of the sequence. The numerator 3, 4, 5, 6, 7, 8. The next one will be 9. The denominator 3, 3, 3, 3, 3, 3. The last denominator is 3. So the next number, the next term is 9 over 3, which is equals 9 divided by 3, 3. We are adding 1 over 3 to each term to find the next one. Plus 1 over 3, plus 1 over 3. So if we add a number to find the next term, is an arithmetic sequence. Letter D. And we have a sequence. All the numbers are negatives, right? So this is a decreasing sequence. It's going down. One thing we can try, the first thing we can try is if we subtract a number from each term to find the next one. Let's try subtracting 2, and then subtracting 2 again, then subtracting 2 again, and again. And yes, it works, right? Negative 10 minus 2, negative 12 is the next term of the sequence. And since we are adding or subtracting a number, it is an arithmetic sequence. And letter F. For letter F, well, it's kind of the same situation, but the first term is a positive, then becomes a negative, then goes down, down, down. I think we can try again. We can try to subtract a number. 1 minus what equals negative 3? 1 minus 4 equals negative 3. Now try again. Minus 4, yes, negative 7, minus 4, negative 11, minus 4, negative 15. And the next will be 15 minus 4, Negative 15, I mean, minus 4, negative 19. Negative 19 is the answer, one of the answers for item F. The other answer for item F is, we are subtracting a number, so again is arithmetic sequence. Thank you, Mia. Let me show a geometric sequence. We have here in the middle, letter E, okay? Let me show letter E. We have 4, negative 12, 36, negative 108. This is an alternating. When you see an alternating sequence, probably is a geometric, because you're going to multiply by a negative number. So let's try to find negative 12 by multiplying 4 by a number. We need to multiply by negative 3. 4 times negative 3, negative 12. And then multiply again by negative 3. Negative 12 times negative 3, negative with negative positive, 12 times 3, 36. Nice. Times negative 3, negative 108. And times negative 3 again. Negative with negative positive, 3 times 108, and we will have 324. That is the answer, 324. Since we are multiplying the term to find the next term, we can say this is a geometric sequence. Thank you, Mia. We have one last minute. Let me show B and H. Let me show K, and I give you the answers. For letter K, we can see all the sequence is negative, but the number, only the number, is decreasing by half, right? 2, then 1, then 1/2, then 1/4. And this is also something that we can find by dividing by 2 or multiplying by 1/2. You can say you are dividing by 2 or multiplying by 1/2. The next term of this sequence, multiply by 1/2. And we have negative 1/8, right? This is the answer. And since we are multiplying or dividing, it's going to be a geometric sequence. And we don't have a lot of time, we don't have more time. Let me give you a few answers.